Let's begin. Today is July 6th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses 5 criteria cards, and it's 5 verification cards. Let's go to turingmachine.info for the details. So today's puzzle uses the following 5 criteria cards. Criteria card 5, 11, 17, 19, and 20. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So our 5 criteria cards are in the grid above. On the top row, we've got criteria card A, criteria card B, and criteria card C. And in the bottom row, we've got criteria card D and criteria card E. Criteria card A looks at our first digit, the triangle digit, and the Turing machine will let us know whether that value should be an even or an odd digit. Criteria card B looks at the first 2 digits, triangle and square, and the Turing machine will let us know which one's bigger. In essence, should triangle be less than square? Should they be equal? Or should triangle be greater than square? Criteria card C will look at the 3-digit solution, and the Turing machine will let us know how many of those digits are even. Should there be 0 even, a single even, perhaps 2 evens, or maybe even all 3 should be even. Criteria card D again looks at our first 2 digits, triangle and square, and will take the sum and then compare the sum to the number 6. So should the sum be less than 6? Should the sum be equal to 6? Or should the sum be greater than 6? And finally, criteria card E will let us know a little bit about the structure of the 3-digit solution. Specifically, the Turing machine will let us know whether there are no repeating digits, as in the example 125, or potentially it could be a double number where a single digit is repeated, as in the example 112, or perhaps it could even be a triple number, a single digit repeated 3 times, as in the example 222. Remember, the objective of the puzzle is to find this unique 3-digit solution and that abides by the 5 criteria cards we discussed earlier. And so we're going to start off with an initial proposal of 314. So before we actually start, there is something very interesting about the cards that we have, and I don't see anything specifically related to circle. That's very interesting. So somehow circle is going to be forced into a particular value. So let's play out and see what we have. So I think the first thing I want to test is I want to see what the value of the first digit, the triangle digit, is. Is it even or odd? So I'm going to test criteria card A. Okay, so the Turing machine approves of my proposal. Notice that I did choose an odd 3. So the Turing machine approves that it is an odd. Maybe not 3 per se, but at least we do know that triangle should be an odd digit. So we'll type in that triangle is an odd digit. And since it is odd, that means I can go ahead and cross out both evens. So cross out number 2 and number 4. All right. So next, I think I'll test criteria card E to see if there's, there are no repeating digits. Perhaps it's a double or maybe even a triple. So let's go ahead and test E. Okay, so it does not approve of my initial proposal of 314. Notice that 314 are indeed unique, meaning there are no repetitions, but the Turing machine does not approve of that. So I'm going to type up that it's either a double number or a triple number. So let me go ahead and type that up or in section E, that the solution is a double or triple number. Okay, And so let's see, is there any way where we can deduce that it's a double or a triple? If it's triple, no, at least not initially. Okay, well, we do know that triangle is odd. So I guess if it is a triple, notice that since triangle is odd and it's a triple number, that would mean that we know that there are 0 even. And I think that's technically not allowed as far as how these puzzles are constructed. So I think I'm going to go and say that in fact it should be a double number. It cannot be a triple for that reason, that if I knew, since I know that triangle's odd, that would mean that they're all odd and there'd be 0 even. So I think it's almost safe to say that there should be at least 1 even. Can we say that? We'll find out. Okay, so we are dealing with a double, and obviously if we knew how many evens there were, we would know, well, which digit, or which or what kind of double is there? Are there 2 evens or 2 odds? Well, I do have a single even, but that doesn't necessarily mean that it would have to be one or the other. It could be that you could have 3 evens, right, and just paired up one of them, or you could have all odd and pair up one of the odds. So I don't think that's going to be helpful. I do find criteria card B interesting. Remember, again, we're trying to force circle to be something. So it could be that, triangle and square might be equal, and therefore circle would be perhaps the lone even. That's a possibility. But I guess if it is, let's talk about that. What if circle were even? I don't see anything there that would force circle to be either a 2 or a 4. I just don't see that. So perhaps then maybe square might be an even, and so somehow the ordering of triangle and square and the sum would lead us to the ideal even and even square and odd triangle, and then circle might be that other odd. So let's see. So I'm thinking that that's what it's going to be. It's going to be odd, even, odd. So I think criteria card B would be a great choice to test. So let me go ahead and test B. Okay, so it does not approve of my proposal of 1 for square and 4 for circle, meaning that either it's going to be square that's greater than circle. I apologize, why am I saying circle? Why am I even looking at circle? It's triangle and square. So going back, I apologize. Triangle is 3, square is 1. So the Turing machine does not approve that triangle should be greater than square. If anything, as I mentioned, it could be equal, or it could be that triangle is less than square. And again, I'm pretty sure that circle cannot be even, because I just don't see anything that would lead me to either a 2 or a 4. Even, maybe, but not a 2 or a 4. And so I'm thinking that, I guess, or even odd for that matter. Which odd would it be? There's no restriction. So yeah, I don't see how circle has to be forced to be, either whatever triangle is or square is, to be honest. Yeah, I've been saying odd, even, odd, but it could be even, even, odd. That's possible. All I know is it's got to be forced, it's got to be equal to one of the others. So, yeah, that would sort of help out if I knew, am I dealing with two evens or three evens? Who knows? All right, so let's type up what I do know, and that is that triangle should be less than square, and that's for B. Triangle should be less than square. And again, I don't think that it could be equal. Even if it were equal, I don't see how circle, you could determine what circle is. Even if it were equal, I just don't see it. So I'm going to say, actually, I'm going to write next to it, I'm going to deduce that it must be triangle is less than square. And if that's the case, that means that triangle can't also be a 5, because if it were 5 and it's smaller than square, what would square be? So it can't be 5, and square can't be 1, because if it's supposed to be the largest and it's 1, what could triangle be? There's nothing less than 1. Okay, so that's it for this turn. We've already done our 3 Turing tests, so now we're going into the phase where we'll be discussing a little bit more about how to construct a good second round proposal. Okay, so again, I am deducing that triangle should be less than square, and everything does look good. So now it comes down to really the sum and the number of evens. So is there anything that's out of bounds? I guess technically you could still have 6, right? Because you could have 1, 1, 5. I guess technically 1, 2, triangle 1 and everything but square 5 is going to be a sum that's less than 6. There's only 1 6, assuming that they're not equal. And the 3 provides 2 sums that are greater than 6, and that's 3, 4, and 3, 5. So let's see. Yeah, again, somehow it's got to be forced. And so I'm thinking one of them has to be even. And let's see, can we say that square and circle are even? Well, we know triangle is odd. I guess that's the thing, right? How would you determine which one is the even? It would almost seem to me that you'd have to have 2 evens, perhaps square and circle, and then somehow the sum should be easy to determine. So it looks like it wouldn't be 2 for square, because both 1 and 3 give you a sum that's less than. So it looks like it would have to be 4. And again, we want to sort of maybe force the issue. So if we made, let's see, if we made the sum, say, greater than 6, and there are 2 evens, it's not going to be 2, it's not going to be 3, it's going to be 4. which would force the triangle to be 3. And then, of course, circle is the other 4. So let me go ahead and test 3, 4, 4 and see where that takes us. Okay, so we did not test C, the number of evens, and we did not test D, the sum. So if I tested the number of evens, I'm pretty sure if I got 2, it wouldn't be 2, 2, because then I wouldn't be able to figure out, well, I guess it could be, I guess if the sum were less than, well, what should I test? Well, I guess the sum will let us know if it's less than or greater than 6. If it's greater, we know it can't be a 1. It would have to be a 3. And it could even be maybe even 3, 5, 5 if there were odds. So, yeah, let me go ahead and test criteria card D just to see the sum. Let's go ahead and do that. Okay, so yes, the sum is definitely greater than 6. So let me go ahead and type that up. And again, that is for criteria D. So in my notes, I'm going to say triangle plus square is greater than 6. And so, of course, that means that, yeah, triangle can't be 1, because there's no way I could ever get a sum of greater than 6 with triangle 1. So that means it's 3, and so that means square can't be 2 or 3, because those either give me a sum that's less than or equal to 6. So we're dealing with 3, 4, 5, and because there is a double, that means a circle can't be 1 and it can't be 2. So I guess technically it could be 3, 4, 3, 3, 5, 3. But again, I'm thinking that it's going to be 2 evens because, well, actually, yeah, that is interesting. Let me see, what if I do type out the possibilities? So it could be 3, 4, 3, and it could be 3. Let's see, how do I want to do this? Let me go ahead and say that the doubles are 3s. So 3, 4, 3 and 3, 5, 3. Okay. And then I could also have 3, 4, 4 or 3, 5, 5. And that looks to be the only cases. 3, 4, 3, 3, 5, 3, 3, 4, 4, and 3, 5, 5. So is there anything that distinguishes 3, 5, 3 and 3, 5, 5? Those are all odds. The first one's odd. Oh, I can't have, I forgot my rule about triangle. Oh, that's interesting. Oh, that is very interesting. Let me see. I don't think any of those actually fit. Oh, it's triangle. Never mind. Yeah, 3, 4, 3, 5. Oh, yeah, they all fit. Again, for some reason I was looking at circle. Okay, so yes, they all do fit with criteria card B, that triangle should be less than square. And the first one's always odd. Okay, so 3, 5, 3 and 3, 5, 5, there are 0 evens. the sum are both greater than 6, and they're both double. So I would say that these two I can eliminate because they seem to be ambiguous, at least with the first and third one, or the last two that I have. There's either 1 even or 2 even, and so I do have the 2 even variety, so I don't think I can deduce. Let's see, if there is 1 even, then at this point, yeah, it would have to be 3, 4, 3. And if there are 2 evens, it would have to be 3, 4, 4. Yeah, I don't see anything where I can deduce. So let me go ahead and test criteria card C. Okay, so yeah, so we do have the 2 evens, and so it looks to be that the solution should be 3, 4, 4. Since the Turing machine did agree with my proposal. Okay, and so yeah, so it looks like, I think based on our previous checklist, I think it meets all the criteria. And so let me just type up in section C that there are 2 even digits. Okay, so let's go check with the Turing machine. Let's verify our code of 344. Fantastic, we've got that. And so let's actually compare our results with the Turing machine. So it looks like the first round we did A, B, E. The first one was correct. And in the second round we got both C and D correct. So A, B, E. B and E were wrong. Second round, C and D were correct. So let's go ahead and test. Wow, I'm actually surprised that the Turing machine took 7 queries, 7 Turing tests in 3 rounds, but we were able to get it in 5. Not sure what I would attribute that to. Maybe a little bit of luck on our part. It definitely did help to know that we did deduce that triangle was less than square, and we were able to figure out that there should be a double. But otherwise, I think it was a great solve. If you did notice anything that you'd like to share, please do add that to the comments. If you liked the video, please give it a thumbs up so that more people can find this channel. And of course, if you do not want to miss out on any future videos, please hit subscribe to be notified of when the next video is available. Well, until next time, have a great one.